All right, so quickly, just a couple of reminders, guys. So our reactions assignment that we worked on Wednesday and Thursday, that is going to be due on March the 9th, so make sure you've got it ready to hand in at the start of class on that day. Okay, and your reactions lab is due March 7th, since that's coming in on Google Classroom. 8:30 a.m. is when I would like that one. Okay, so if you're handing the stuff in on paper, you can hand it in to me in class. I don't expect you to make your way here for 8:30. Okay, but when it's electronic, I expect it comes in at 8:30 a.m. All right, so make sure you have both of those things ready for next week. Okay, so they can be marked and returned to you quickly. On Monday at 8 a.m., the unit exam review will post on Google Classroom. I've got it scheduled to come out at that time, and that will include some review activities and a practice exam and a key for both. All right, so you can do them and then check your answers, and I would suggest doing that over the course of that week, and if anything gives you trouble, then you know what you need to come in and ask me about it help. All right? Okay. So the last topic in this unit is the mole and the mole equation. Okay. Now, I don't know why it's called the mole. I have no idea. Except that the guy that came up with it kind of looks like one. And not like you know, something on someone's face, but like the animal, the mole. Okay, like kind of looks like that. Okay, I don't know. Maybe that was a nickname. I don't know. The unit of a mole is used to tell us how much of something there is. Okay? And there's lots of different ways for us to do that. We can tell somebody that they have X many grams or X many kilograms of something, or they have X many liters of something. We can use volume, or we can use mass. Okay? Moles tells us how many particles there would be of a particular substance. Okay? So a mole is a representative number, okay? And it works kind of like this. If I said to you, I have a dozen donuts, how many donuts do I have? I have 12, because a dozen always stands for 12. Okay. A mole always stands for that many. Not nearly as convenient as 12, okay? But it's always that many. If I have a mole of water, I have 6.02 times 10 to the 23 molecules of water. Okay? If I have 1 mole of gold, I have 6.02 times 10 to the 23 atoms of gold. Okay? I have that many particles of that material, whether it's a molecule or an atom, that is always 1 mole. Okay, everybody with me there? Okay, so how many people understand what I mean when I write it like that in scientific notation? Okay, you guys took that in math, right? Okay, so what this really means is 602 with 21 zeros behind it. Okay, we obviously don't want to have to write that every single time, so we put it in scientific notation because it's shorter. Is that a big number? It's huge. Okay, like 602 with 21 zeros behind it is a gigantic number. Okay, so when we're talking about a mole, we're talking about a large number of particles. Are we necessarily talking about a large amount of it that we could hold in our hand? Not necessarily, because atoms are really, really what? Small. Really, really small. Okay? To give you an idea, if I had that many molecules of water, it would barely fill the cap of a water bottle. I would have about 18 grams or 18 milliliters of water, about a teaspoon. Okay, so it's not much. It sounds like a lot because atoms are very, very small. Molecules are very, very small. Okay? But a mole is an easier way to represent a large number of things. So if I say I have 2 moles of something, I'm saying I have 2 times this number, which is way easier than saying this number. Agreed? Okay, so that's the purpose of a mole, is to have a number, like a dozen is always 12, that represents a specific number of something. Okay? Now, you're probably wondering, well, why in the hell did they pick that number? Couldn't they have picked 12? Like, it would have been way easier, okay, to pick like a nice round number. And the reason is that this number was actually what they arrived at when they tried to do this with the simplest atoms. What's the simplest element on the periodic table? Hydrogen. Okay? In a typical hydrogen atom, there's one proton and one electron. What's the atomic mass of hydrogen on the periodic table? 1.1. Right, 1.01. Okay, so like basically 1 gram. Okay, and that's kind of what they were working on. They said, let's figure out this number based on the simplest atom we have, hydrogen, because we know the mass of a proton and we know the mass of an electron. So we can figure out how many atoms of hydrogen are in 1 gram of hydrogen. Okay, because it's a simple atom. So that's what they did. And they found it was that many. Okay, and then they went from there. That's why every single element on the periodic table has a different atomic mass. As we go along the periodic table, elements get bigger. Atoms get bigger. They have more protons, they have more neutrons, they have more electrons. And so 1 mole of them has a bigger mass. Okay? So these numbers that you see here, the atomic masses, are the mass of that many atoms of each one of these elements. Okay? So if I had 6.02 times 10 to the 23 atoms of lithium, it would have a mass of 6.94 grams. Okay? If I had 6.02 times 10 to the 23 atoms of lead, it would have a mass of 207.2 grams. Because lead atoms are way bigger than lithium atoms. They have way more protons, neutrons, and electrons. Okay? So, if somebody says they have 1 mole, that's how many they have. If they say they have 5 moles, they have how many times that number? 5. Okay? So if I told you I had 4 dozen eggs, I have how many? Don't say 4 dozen. Somebody did that to me and I got burned off. 48. 4 times 12. Okay? If I say I have 4 moles, it's 4 times that number. Okay? Now, a little bit of a trick. How do I put that number in my calculator? Okay? I have to put it in brackets. Okay, so if you have a scientific calculator, or if you have the TI calculator, let me go with the TI. Okay, now, by the way, you're going to need to bring your calculator next week. Every day next week, bring your calculator to this class. You're going to need it. All right, so what I would do is I would put a bracket, and then I would go 6.02, and then I'd hit the second function, and I'd hit the comma button. Above the comma button are 2 capital E's. Oddly, when I press it, I only get 1, but that's okay, that's what I want. Okay, that means times 10, and then the next number I put in is the exponent. That's how I put that into my calculator. Now I have 6.02 times 10 to the power of 23 in my calculator. If you don't have a TI-83, okay, or 84, or 85, or whatever the hell we're on now, okay, you may have one of 2 buttons. You may have that button, EXP, that serves the same purpose as the double E button I used, or you may just have a double E button. Okay? In either case, that's the button that you would push, and sometimes on scientific calculators, when you push that, it actually shows a little 10 time, like X10, and then you can put in the power after that. That can help you out when you're entering that in your calculator later. Okay. For today, you can use your phone as a calculator, but obviously you can't have your phone on the unit exam, so you need to beg, borrow, or creatively acquire a calculator, okay, before your unit exam, because you can't use your phone as a calculator on the unit exam. Okay? All right, questions so far? All right, so that's what a mole is, okay? We'll talk a little bit more about that, okay? And then we're going to talk about the relationship between moles, mass, and molar mass, and use the mole equation to solve problems, okay? So there's going to be a bit of math here now. That's the mole equation. N equals little m over big M. It is on the back of your periodic table, so you don't have to memorize it, okay? But it is something we're going to use quite a bit over the next little while. And you will have to manipulate it. Okay? You will have to solve for something other than n. You will have to solve for little m. You will never have to use this equation to solve for big M. Okay? And I'll show you why in a minute. It'll show you how to calculate big M. So how do we manipulate this equation? What do we use? Keeping in mind that if you say triangle, I will get very, very angry. That's what I was afraid of. Everyone was thinking I'd use a triangle. Okay, just so you know, I know that somewhere along the way, some very well-meaning science teacher showed you that triangles are useful tools for doing algebra. That kind, well-meaning science teacher was horribly, horribly wrong. Okay? Because while a triangle might work for this formula, it sure won't work for this one. Which you will use in this course, in the physics unit. It also won't work for this one. Which we will use that one later on in the physics unit. Okay? Or possibly this one. There's just no triangles for those. And you won't find a trapezoid or a rhombus or any other shape that's going to do the trick for you. Okay? You're just going to have to do algebra. Don't worry, algebra is easy. Even I can do it. Okay? Like, I was never a very strong math student. Okay? Like right now, I'm looking at what my son is doing in Math 10 and it hurts my brain. Okay? But I can do algebra because it's like grade 8 math. Okay? And I can do that. Okay? So I'll show you the tricks for algebra. There's only 3 rules. Those 3 rules got me through university physics. And not to brag, but I did pretty good in that because I only had to do algebra. Calculus, that's another story. Okay? But anything that's just linear algebra, okay, you guys can handle that. It's not that hard. You don't need a triangle for it. And don't draw triangles on anything. It enrages me. It's triggering. Don't use triangles. All right. So, looking at the mole here. Okay, so as we said, okay, a mole is just like a dozen. It represents a specific set number of particles, this many. Okay, 6.02 times 10 to the 23, and that is Avogadro's number. Okay, because he's the guy who looks like a mole and came up with it. And of course, because we're very, very busy, we abbreviate mole by dropping the E. Okay? It saves us a lot of time. Just like an abbreviation for at saves us a lot of time because we're very, very busy. Okay? So we will abbreviate it MOL. Don't abbreviate it M. M already stands for something. Okay? We don't want to confuse moles with meters. Okay, so MOL is the abbreviation for moles. Okay, now, I can always calculate the molar mass, or the mass of 1 mole of any material. Okay? If it's just an element, I can read it directly off the periodic table. I don't have to do any calculating. If they say you have 1 mole, or what's the mass of 1 mole of calcium? It's 40.08 grams per mole. Okay? What if I have a compound? How would I figure out the mass of 1 mole of a compound? Because the compounds aren't listed up here. Only the elements are listed there. Do you divide it? I wouldn't divide it, but if I know what the molecule the compound is made up of, could I add? Yeah. Okay, so let's look at water as an example. Okay? A molecule of water contains 2 hydrogen atoms and 1 oxygen atom. Agreed? Okay. According to my periodic table, the molar mass of hydrogen is 1.01. How many hydrogen atoms do I have? 2. Okay, so I would go 1.01 times 2, that'll take care of my hydrogens, plus the atomic mass of oxygen, which according to my periodic table is 16. Okay? So that tells me then that if I have 6.02 times 10 to the 23 molecules of water, it'll have a mass of 18.02 grams. Okay, so I take the parts of the molecule, okay, I look up what the atomic mass is of the elements, I do any multiplication that's necessary, and then I add them all up. Okay, it's not difficult math. All right, see if you guys can get this one. How many potassium do we have? 2. Okay, so we go 39.10 times 2 plus how many oxygens? 1, which has a mass of 16. Yeah, so we add 16. Sorry, I was asking how many oxygens. There's only 1 oxygen there, but yeah, you're right. Its atomic mass is 16. All right, so when we punch that in, okay, we're going to have 39.1 times 2 plus 16. Whoop. Oh, I had the answer in there. Okay, that didn't make any sense. 39.10 okay, times 2 plus 16. All right, so we're looking at 94.20. And the units for that are grams per mole, because that is the mass of 1 mole, okay, or 6.02 times 10 to the 23 particles. Okay, does that make sense? Okay, I want you to calculate the molar mass, those 5 things. They get progressively more involved. All right, because you have to figure out how many of each element there are, because you got to do it element by element. Okay, I'll give you a few minutes. Let's look at the first couple here. Okay, so sodium chloride, pretty straightforward. Okay, I take the mass of sodium, which is 22.99, and I add it, because there's only 1 of them, right? And there's only 1 chlorine, so I would go 35.45. Okay, add those 2 together, what do I get? 58 point something. 58.44. Okay, and my units are grams per mole. Make sure you put units on it. Okay, otherwise I don't know if it's grams per mole, apples, oranges, old ladies with walkers. You have to have units on there so I know what it is. Okay, all right. Number 2, I've got iron and bromine together. How many irons are there here? 1. Just 1. All right, so I'd go 55.85. Okay, and then I add it to how many bromines? 3. So 79.90 times 3. All right, so 295.55 grams per mole. Okay? Everyone kind of seeing what we do there? Okay, the little numbers tell us what we got to multiply by. Now, that gets a little bit more involved when you've got a polyatomic ion in brackets. Okay, I got to go element by element, right? How many nitrogens are there? How many hydrogens are there? Okay, put in that multiple. Okay, let's look at number 3, and then I'll give you guys some time on 4 and 5. So for number 3, we got phosphorus, and how many are there? All right, so 30.97 times 2 plus 5 oxygens, so 16 times 5. All right, so 141.94 grams per mole. Okay, all right, I'll give you a little bit more time on those 2 that have the polyatomic ions, and then we'll walk through those. All right, so the trick with these is being able to interpret the chemical compound so that we know from its formula how many of everything there is. Okay, so since I've got NH4 in brackets with a 2 outside the brackets, that means there's 2 NH4s. So there's how many nitrogens? 2. Yeah. So I'm going to go 14.01 times 2. That takes care of my nitrogens. How many hydrogens are there? 8. 4 times 2 is 8. So plus 1.01, the mass of hydrogen, times 8 hydrogens, plus 1 sulfur, so 32.07, 06, 7. Okay, and then plus 4 oxygens, so 16 times 4. Okay, so I just have to be able to interpret the formula so that I know how many of everything there is. Okay, so we'll have 28.02, that's our nitrogens, okay, plus 8.08, that's our hydrogens, plus 32.07, that's our sulfur, plus 48. No, 64. Okay, that's our oxygens. Right, so that's going to be 132.17 grams per mole. Okay, and then for number 5, we've got scandium carbonate. Okay, there's 2 scandiums. 44.96 times 2 plus 12.01. That's my carbon, but how many are there? 3. So times 3 plus how many oxygen are there? 9. Okay, so 44.96 times 2 plus 12.01 times 3 plus 16 times 9. Okay, so 269.95. grams per mole. Okay, everybody all right with that? That's always how we calculate molar mass, or capital M, from the mole equation. You'll never have to use the mole equation, in Science 10 anyway, to calculate the molar mass. You're always going to get it from the periodic table. All right? Okay. Now, when we look at a chemical reaction, okay, we can interpret it in a number of ways. If we have it balanced, it could be read literally. And that literally means I have 1 molecule of nitrogen, I have 3 molecules of hydrogen, and when they combine in a synthesis reaction, they make 2 molecules of ammonia. Okay? I could read it literally like that. Would I even notice that reaction if it was literally 2 molecules, 3 molecules making 2 molecules? Never. Okay? You would never observe that because it's too small. Okay? Typically, the way a chemical reaction is interpreted is I have 1 mole of nitrogen gas, 3 moles of hydrogen gas, and they combine to form 2 moles of nitrogen trihydride, or ammonia. Okay? That is typically how we interpret the balancing numbers to be read in that. Would I notice that reaction? Probably. It's a lot more. Okay? I mean, we're talking about exponentially more material than if I interpret that equation literally. Okay? Now, in Science 10, you're not required to do this, but it's one of the first things you do in Chem 20. And that is, if I know how many grams of hydrogen gas I have, I can calculate how many grams of nitrogen trihydride I would produce as a result. Okay? It's called stoichiometry. It's one of the first things you'll do in Chem 20. We are no longer required to do it in Science 10. Okay? All we're going to be required to do is work with single atoms or compounds in calculating their mass. Okay? Okay, that's Avogadro. Right? It kind of looks like a mole. I don't know what it is. It's like the thin shoulders. The cut of his suit is terrible. Okay? It's like, but he's like got no shoulders or something. He's got like the sunken eyes. Okay, now, just to have a little bit of fun. So if we're looking at the mole equation, okay, the mole equation goes like this, okay, where n equals little m over big M. Now, n is the number of moles. Okay, so n stands for the number of moles, so it's always going to be in moles. Okay, little m is the mass of the material, and that's always going to be in grams. Okay, so little m stands for the mass of the material in grams. Okay, and big M is the molar mass. That's what we were just calculating. Okay, and that is always going to be in grams per mole. Okay, so the way this equation is set up, I would be dividing grams by grams per mole. So the grams would cancel, and I'll be left with moles. Okay. Now, let's say I want to manipulate this equation. Right now it solves for moles. The only manipulation I have to perform of this equation is to solve for little m, the mass. So how do I get little m by itself?
Move the big M to the side of n.
Right, move the big M to the side with n. Now, how would I do that? Right now I'm dividing by big M. So if I want to move something, I do the opposite. Okay, that's the first rule of algebra. Okay, the first rule of algebra is if you want to move a variable, you perform the opposite operation. Right now I'm dividing by m, so if I want to move m, big M, I would multiply both sides by it. Okay, so that means I would go times big M. Now there's a big M on the top and a big M on the bottom. Okay? Second rule of algebra. What you do to one side, you do to the other. Okay, well, now big M is over on the other side, and I'm done. Okay, there's a third rule of algebra, but we don't even need it in chemistry. Okay, we'll need it when we get to physics, but we don't need it in chemistry because this is the only formula we're going to use. Okay, the third rule of algebra, in case you're curious, is you should move what's not attached to what you're looking for first. And it kind of helps you preserve the order of operations in a longer equation. It's not necessary here because there's only 3 variables. Right? So that's the only manipulation that you're going to have to do. Okay, is, all right, I got to move M over, whoops. That's not what I want. I just have to move M over here, and I'm done. Okay, that's the only manipulation we're going to have to do of that formula. Okay. We'll concentrate on algebra when we get to physics. All right, everybody good with that? Okay. So let's look at, yeah, we got time for an example or two here. All right, there's only 4 ways I can ask you a mole equation problem. Okay, we're going to go through all 4. So I want you to write this one down. This is the first way that I can ask you a mole equation problem. The first 2 are very simple, and the second 2 add 1 extra step involving Avogadro's number, the 6.02 times 10 to the 23. Okay, so just write this one down and then we'll go through it. All right, so for a question like this, okay, and for any problem that we have to solve, be it chemistry or physics, the first step is to write down what we call our givens. That is, what numbers or quantities did the question give me? Right? So in this case, the question is saying, how many moles? So I know right off the bat then that they want me to calculate what little n is. Okay. The next thing they tell me is that the material I'm dealing with is calcium chloride. That can help me to get the molar mass. Okay. So if they tell me the material I'm dealing with, I can calculate big M. Right, so I got CaCl2. And calculating the molar mass of this stuff means going 40.08. That's the molar mass of calcium. Okay, plus 35.45 times 2. That's the atomic mass or molar mass of chlorine, and there's 2 chlorine, so I multiply it by 2. Okay, that should give me 110.98 grams per mole, I think. I probably shouldn't do math in my head, but I did think it's right. Okay. All right, and then they tell me 90 grams. What part of the mole equation did they give me there? Little m, right, because little m is mass in grams. Okay, so on a quiz or unit exam, that's a mark. Okay, you would get a mark for writing your givens out. Now, I'm trying to find n. I know big M and I know little m. So, my next step then would be, this is the formula I would have to use. Okay. Do I have to manipulate it at all? I don't, right? I'm trying to solve for n. This formula is already set up to solve for n. So all I have to do is put my numbers in. Okay? I just said that little m was 90 grams. And I said, or I calculated that capital M was 110.98 grams per mole. Okay, so I have 90 grams. 1 mole is 110.98. I don't even have a whole mole here, do I? Okay, so is it okay if I get a decimal here? It's absolutely okay. All right, so we're going to have 90 divided by 110.98. All right, so I have 0.811 moles. Okay. I would say probably 2 decimal places is enough. And I know I wrote 3 there, but 2 decimal places would probably be enough here. All right, so that would likely be a 3-mark question. I would give you a mark for your givens, a mark for your math, which only involved plugging numbers in, and a mark for your final answer. Okay. Everybody follow what I did there? Okay. That's the easiest mole equation question you're going to get, because you don't have to do any algebra, right? You just plug in numbers and solve and you're done. All right. Write this one down. Give it a try. We're looking for the mass this time. They tell us how many moles, and they tell us the material, magnesium bromide. Okay. I don't know if we'll get this one done before we run out of time, but let's just have a look at least the givens here. So it says, what's the mass? So that means I'm looking for little m. They tell me that n, the number of moles, is 4.5. Okay? And they tell me it's magnesium bromide, but they gave it to me in words. Does that make it a little trickier than if they gave me the formula? It does, because if I don't drop and swap this correctly, am I going to get the molar mass right? I'm not. Okay, so it's pretty important, again, to be able to get those formulas right. So we got MgBr. Mg is a 2 plus, bromine's a minus 1. So we're looking at MgBr2. So that's going to be 24.31 plus 79.9 times 2. I think those numbers are right. Okay, so 184.11 grams per mole. Okay, so I've got N, and I've got big M, and I'm looking for M, little m. Okay, so if I want to solve for mass, little m, what do I have to do with big M? Oh, I'm already dividing it. If I want to move it, I do the opposite. So I want to multiply both sides by big M. Right? Now I'm solving for little m, and I just have to plug in my numbers. So that'll be 184.11 times 4.5. So we're looking at 828.50 grams. All right, we'll be looking at that more next week. Have a good weekend, but not too good. Make sure you get your lab done for next week. Thank you.